Hi, good day. My name is Kunti Dixon, and to right with me are my fellow group members. Together we are Group K, and I've been challenged by a large-scale citrus farmer to design a device with the ability to juice his product on site. To complete this task, each member came with specialized skills, and together we created a solution for this farmer's problem. With that in mind, the skills I contributed were critical thinking and conceptual thinking, planning and organization, writing, and drawing.
Hi, my name is Ryan Anand, and I contributed in organizational and conceptual skills, as well as attention to detail, ensuring efficiency. This was extended to the areas of SolidWorks, as well as the various charts necessary to critique the designs.
My name is Shakila Ravello, and I contributed literary skills, proficiency in Microsoft programs, and capabilities in SolidWorks. I used these skills to assist with developing a concept design, producing a SolidWorks design, sourcing and compiling patterns, and producing the PowerPoint presentation.
Hi, my name is Christian Sylvester, and I contributed creativity, innovative ideas, assistance, and technical aspects in further mitigation of the design process. In combination of these selective skills, I assisted my group with particular preliminary developments, producing concept design, literature review, background, patent review, followed by editing and comprising the final PowerPoint presentation.
Background. In 1945, the automatic citrus juicer was the first of its kind, and it was mainly used in hotels and restaurants in New York City. Today, orange juicer is one of the most common forms of juicers found in every household. Citrus juicers are made specifically for extracting juices from citrus fruits by firstly shredding the flesh, followed by squeezing the fruit to begin the flow of the juice. Whether you are hoping to juice an orange, lemon, lime, or even something as large as grapefruit, most citrus juicers will be able to accommodate your needs. They are not, however, suitable for extracting juices from other types of fruits and or vegetables. You will not be able to juice apples, pears, pineapples, carrots, or anything which is not a citrus fruit. Before citrus juicers were invented, fruits and vegetables were crushed or pressed to extract the juice. Since the first automatic citrus juicer was designed, the appliance changed a lot to what is available on the market today. Currently, there are different types of citrus juicers for small or large amounts of fruits. Knowledge of the farmer's situations was taken into consideration so that our team would further mitigate the task in such a way that the farmer gets his job completed effortlessly and efficiently. Project statement. As the farmer does not have the necessary space to transport the fruits from the farm to the market, there is need for a device that can juice the product on site and maximizes the space currently available. The farmer hopes to use the device in the field to maximize efficiency and use as minimal effect as possible in the juicing process. Furthermore, considering the farmer would be working alone, it is desirable that only one person is required to move and operate the device. Project aim. The engineering team is required to design such a device to extract the fruit juices at an efficient rate without any assistance from the farmer, but also be rugged enough to withstand harsh external conditions when in the field. It should also maintain total functionality while being robust enough to be easily moved. Literature review. The first patent of the modern citrus juicer was issued to Louis S. Chichester on July 3, 1860. Citrus fruits have been cultivated for over 4,000 years and are the most produced fruit crops in the world. Juice is the primary product obtained from citrus fruits, and it is also one of the most important commodities. The citrus juices contain vitamins, minerals, carotenoids, sugars, organic acids, amino acids, phenolic, 9 nucleotides, enzymes, limonoids, lipids, proteins, pectins, and other soluble and insoluble solids. Each juice vesicle contains cells that consist primarily of enlarged vacuoles of
Patents
juice.
that inspired the design are as follows. The first patent is an automatic orange juicer that automatically crushes the fruit and separates the rind from the juice. As shown in Figure 1, the oranges are fed to a hopper labeled as 26, which carries the fruit to a cutter indicated as 22. After being cut, the fruit travels to spaced rolls to be crushed and the peels fall to the receptacle labeled as 10 and 36 respectively. However, the juice is separated and goes through component 14, the spout. The second patent is of a citrus juicer machine that extracts the juice using squeezers, collects the juice, and disposes of the peels. The fruits are fed from the bin, including an elevator listed as 35 as seen in the figure. This elevator descends, taking the oranges to the chute identified as 59. The oranges then flow to the cutting mechanic. At this stage, there are top squeezers and a knife that cut the fruits into halves and move them along to lower squeezers to be juiced, and lastly, directing the peels to the trash can. The third patent selected shows an automatic citrus fruit juicer that juices the fruit by crushing means. The fruits are led to a blade shown as component 18 in the figures, and the halves are assisted by diverging curved profiles identified as 19A and 19B to a pair of laterally pressing drums where they are crushed by sharp teeth. These drums have holes along their surface to filter the juice, and the fruit waste is disposed of through a chute. The final patent is of a citrus juice extractor that juices by reaming. The fruits enter through an inlet shown as component 25 in the figure, which is connected to a blade to be cut and synchronously rotating reamers that extract the juice labeled as 20, 22, and 23 respectively. After which, peel ejectors remove the peels through an outlet listed as 33, while a pulp and juice separator push the pulp through a pulp gate for filtering seen in the figure as component 37. The client user requirements. The client requires the machine to automatically feed the fruit to be cut, juice the fruit without juicing the peel, efficiently juice the fruit, be easily carried through the field, be an inexpensive purchase, and be easy to operate. The design specifications. The machine is required to self-feed the fruit to be juiced, separate the fruit from the peel or the rind, cut the fruit, be robust, be affordable, and be
Key attributes: efficient, portable, affordable, user-friendly, easy to maintain, and robust. The metrics table is ranked from 1 to 3, 1 being the least desirable and 3 being the most desirable. Example: user-friendliness. Complex to use falls under 1, easy to use falls under 3. Easy to use being the most desirable. The pairwise comparison chart ranks the key attributes to accumulate a relative weighting. According to the table, the highest rating being robustness, this being the most influential attribute. Functional analysis, or black box, is based on input processing and output. Fruit and energy goes into the citrus juicer, giving an output of juice, fruit peel, rind, seeds, noise, and heat. With the functional decomposition chart, the process is broken down further. Fresh fruit is placed, then cut, juiced using some form of energy, in this case compression, filtration, ridding of the waste, then juice collection. Functional means 3. Automatic juicing. Juicing process with the cutting and the rind. This becomes our main function in obtaining the juice. Cutting the fruit using a stationary blade, compressing the fruit for juicing, filtering the fruit, and collecting the juice in a container. The morphological chart shows multiple options in which an action can be carried out. Example: feeding. This can be done automatically, or this can be done
Now
manually.
that we have an idea of the design parameters, we can look at the concepts our team created based on these. Here we have the first design, Concept 1. This concept uses an electrical motor to turn a shaft via belt with rollers, creating a crushing effect on the fruit. The same roller is used to separate the waste products as it forces it into the bins while the juice is filtered into containers. This design requires no input other than the fruits placed at the top. Now we have Concept 2, which also uses an electric motor, but the difference in this design is that the motor spins the pipes extracting the juice through a centrifugal method. Concept 2, like Concept 1, sends the extracts two separate parts to prevent any mixing between products and waste. Also like the previous concept, the only input required is the fruit into the container. Our last design is Concept 3. Here we have a unique complex design that uses an automated hydraulic press to both cut and extract the juice from the fruit. The system uses a sliding filter that removes the waste by using a specialized plate governed by a sensor opening after juice is extracted. When filtered, however, the juice is still in contact with the waste product, and this is the difference between this concept and others. The similarities between the three concepts lie in the input, because this concept also uses one input, which is the fruit placement. Concept ratings. All concepts were ranked against each other for the various key attributes. Concept 3 ranked highest for robustness and portability, whereas Concept 2 ranked highest for efficiency, with Concept 1 ranking highest in cost, user-friendliness, and maintenance. Design selection. The relative weighting scores from the pairwise chart combined with the concept ratings gives us the Pew chart. This chart helps select the best overall design to be used for our final design. The totals show us that Concept 1 scored the highest, therefore we'll be using this as our final design. Final design. As seen in the Pew chart, Concept 1 was chosen as our final design. Here we can see 4 engineering drawing views of our Concept 1 design chosen. Now we will go through our juice extraction process using our final design. Step 1. Place fruit into the top of the container, and its vertical position allows the fruit to automatically roll into the tubes, which it goes on to Step 2. Step 2 is where a roller is placed at the elbow, causing the fruit to roll into the stationary blade at Step 3. At Step 3, the fruit is cut and sliced into halves and goes into separate shoots, going down to Step 4 at the rollers. At the rollers at Step 4, the motor-driven shaft is turning the rollers, applying a force at the elbow where the roller crushes the fruit and the juice is extracted through the slits at the back of this elbow. The slits are placed above a container that allows the juice to fill after time, and this container is comprised with handles, making it easier to move. Now at Step 5, the roller is still in contact with the fruit remains, and this waste product is thrown into a bin that can be used as a container or used as a holder for garbage bags. As the garbage bag is filled, it can be removed out of the bin easily, or if the bin is used, the bin can be removed easily when filled with waste.